In Algebra 233, we're dealing with linear programming. So basically, we're taking what we learned in the last section and we're giving it a real-life application. Linear programming is used in situations like businesses, where companies are trying to figure out how to maximize costs and maximize profits and minimize costs. So basically, if we're going to sell this phone, what's the most that we can sell this phone that people will still buy it, but we'll get the most profit from it because this is how much it costs. Can we switch out some parts? All that sort of stuff deals with a lot of linear programming. Like, what is our range that we're dealing with? So, in order for you to, and linear programming is of course such a big topic, but we're just going to go through the basics in this section, just to give you the basics of linear programming. There's something called a bounded and unbounded type of graph, and what we're dealing with is you're just graphing a whole bunch of linear inequalities in one graph, right? And these vertexes will start to form, okay, where the graphs will cut off. This is called bounded. That means everything is trapped, and the shaded region is where all of the linear inequalities overlap. In this one, unbounded is that it doesn't necessarily close off like this one does. Like the third line doesn't close it off. So you have shading that goes kind of spills out. Our steps are, you just got to graph all the inequalities, and the solution is where shading overlaps. Okay, so this would be where the solution is. This would be the solution. Then you're gonna find the vertex. Some will only have 2 for the unbounded. This will have 3, and then they give you a function to put it in. This is when you're gonna find the minimum and the maximum value for that information, right? So it might be a little bit overwhelming. I'm going to go over it with you, a problem with you, and hopefully it'll make more sense. But just remember that we're going to first just graph all inequalities, so it's a little bit more work than last section. And then once we find these vertex, then we're going to plug it into the equation. And I'll show you what they made. So go ahead and pause, write this down. So they'll give you something like this, where they give you these different inequalities, and then they give you a function, f of x, y. So that means this is the function that has an x and y. This is not anything that I need to separate, please understand. But this comma x minus y means I'm going to take the vertices of each of my graphs, bounded or unbounded, and I'm going to plug it in. And whatever number gives me the smallest number, that's my minimum. Whatever number gives me the biggest number is my maximum. Now, if I deal with an unbounded, for example this one will have no minimum because it goes all the way down, but it will have a maximum. This one will have a minimum and a maximum, right? So let's get started. The first one I'm going to graph x is less than or equal to 5. So basically with these x equals and y equals, I just need to find the x and y. Very straightforward. Here, I'm going to find 5 on x, 1, 2, 3, 4, 5. Okay, and because there's a line underneath, I'm going to just go straight down. See how that works? That means no matter what y is, doesn't matter because x will always be 5. And I'm going to test 0, 0. So that means is 0 less than or equal to 5? This is true. So because it is, I'm going to shade all of the region. I'm just going to do some light shading just because I'm interested in mainly seeing where they overlap. Next, we're doing y is less than or equal to 4. So I'm going to find 4 on y, 1, 2, 3, 4. And this is also a line underneath, so I'm going to do solid. So I have one vertex here. This is 5, 4. Okay? And I'm going to test 0, 0. So this will be 0 is less than or equal to 4. This is true. So I'm going to shade everything that has to do Now I know for sure this region is not in it, so I can keep going, or I'm just going to leave it here because I know that it's just narrowed it down to this. The next one is x plus y is greater than or equal to 2. So I need to put it into y equals mx plus b form. So I'm going to subtract x. Oh, first I'm going to do x plus, I'm going to treat it with an equal sign. Then minus x on both sides, I end up with y equals negative 1 over 1x plus 2, right? Because negative x is the same thing as negative 1, and put it fraction is negative 1 over 1. So I'm going to start at 2, and I'm going to go down 1 over 1, down 1 over 1. I'm going to go, I can put the negative on the bottom and go up 1, back 1, up 1, back 1. The reason why I want to keep going is so I can find the exact point, which is 2, 1, 2, 3, 4. This is 2, comma 4. And I'm going to keep going down 1 over 1, down 1 over 1, down 1 over 1. And this one, this vertex is 1, 2, 3 over 5. And this is solid as well. Ooh. That's not the best looking graph, but what are you going to do, right? Okay? So I found the vertex, but I need to test to see where the shaded is. So I'm going to test 0, 0 to my original. So 0 plus 0 is greater than 2. This 0 is greater than 2 is false. So because 0 is on this side, I'm going to go ahead and shade on this side. Now I know it's none of these because blue and purple, so I'm just going to shade in there. Okay? So this is now our bounded region right here. If it wants, it's bounded because it's closed. If you want to see it super clear, I would just take another color. Color it in. And then no, shade it in. And we have our 3 vertices. Our 3 vertices is 2, comma 4, 3, comma 5, and 5, comma 4. And we have to plug it into the equation, this one right here, f of x minus y. Okay? I'm writing this because I don't have enough space, so I'm going to put this down. I'll put it back up to show you the number, but I'm going to put this down so we can work on finding the minimum and maximum value. So far we find the solution. We did the first part right here, right? The next part is we have to plug in to find our maximum and minimum value, because this is the whole point of doing the linear program, is to find the maximum and minimum. So go ahead and write this down. Pause it, write it down, whatever you need to do. I hope you were able to see that. Pause. So here we're going to make our chart. Here's our x and y. Our equation is 3x minus 2y, and this is our value. So we have 2, comma 4, 3, comma 5, 5, comma 4. So let's do some work. 3 times 2 minus 2 times 4 is 6 minus 8, which is negative 2. 3 times 3 minus 2 times 5, which is 9 minus 10, which is negative 1. And then 3 times 5 minus 2 times 4, which is 15 minus 8, which is positive 7. Right? So our maximum value, right, is 7. And our minimum value is negative 2. one more time. I found this 7 and negative 2 by taking the points, the vertex. These are my vertex. This is given to me. And I plug each vertex into the x and y of this equation to give me my answer. Okay? And this vertex gives me my minimum value, negative 2. And this vertex gives my maximum. Right? So, that was pretty long. So go ahead and write this down. And I want you to try page 157, number 2, 157, number 2. And we'll cover any questions. I'll see you in class.